Good morning, everyone.
Morning.
It's a pleasure to see all of you, meet all of you, and know that you are out there in your little boxes. Very much appreciate your attention here. I'm Betsy Cantwell. I am the Senior Vice President for Research and Innovation at the University of Arizona. And I am here today to really introduce you to both Restruct and this particular symposium, which is on the built environment research for mid-pandemic adaptation, the first of two symposiums where we bring our Restruct ideas and initiatives to the pandemic. I'm noticing that my internet is unstable, so I'm going to stop. Well, all right, we'll see how this goes. So Restruct is a University of Arizona strategic initiative. We started strategic planning 2 years ago to put a new strategic plan together for the university. And Restruct, which really began as a clear mandate to rethink the built environment using all of the capabilities that the University of Arizona has. So this strategic initiative supports an approach which brings innovation to the built environment, which is truly transdisciplinary, which means not only is it multiple disciplines involved, but they work together in order to bring a uniform approach that reaches out across all the disciplines, as well as to our civic leaders, our industrial partners, our university partners across the country. Many of you are in this virtual room today. So those built environment challenges come in 4 grand challenge categories, if you will. And each of them, as you'll see, becomes even more crucial as we face the challenges of this pandemic, COVID-19, and the challenges of what we expect may be future pandemics that the globe has to deal with. The first is redressing inequality and injustice by re-envisioning the built environment. The second is creating resilient and efficient urban and rural systems. And I might add the urban-rural system itself, designed for optimal health, and enabling innovation through better decision-making and data analytics and data analysis associated with the built environment. All of these components become, in my mind, as I look at our future for the globe and our future for being a resilient society, into my perspective on how we created the new Arizona Institute for Resilience. And I'd like to ask people to mute if they could, which is a new institute really encompassing all of our research in resilience to include the built environment, which is really what we're going to hear about today. So as I pointed out, this is the first of 2 symposiums. We are taking advantage of a remarkable group of people who have been willing to come together in this symposium and the next, which will address post-pandemic adaptation, and that will be held in April. I don't think the date is selected yet, so if you're interested in this symposium approaching the post-pandemic world, look at restruct.arizona.edu for more information. The purpose of this symposium is to connect ideas and people from the public sector, from academia, from the service sector, nonprofits, and from industry. These 4 hours have been purposefully shaped to introduce ideas and challenges related to the COVID-19 problems that we all are experiencing, so mid-pandemic, and the built environment, and really to create the construct to allow us to dive more deeply into these challenges, to have discussions amongst this broad group of people, and provide all of you who are attending with the opportunity to share your interests, your thoughts and ideas, and what inspires you to think differently. Today's focus provides a fairly general overview of the built environment research challenges that we see, some interesting hacks that have emerged related to COVID. I will certainly say, as the person responsible for managing research broadly at an R1 institution like ours, that successful hacks that I've seen in order to make us safe and operational have been really remarkable. I think our panelists will be very, very interesting to all of you. And I hope they are. I will hang out for a bit. I look forward to the part of this that I'll be able to attend. I want to introduce Steve Winston. Steve will be ringleading you through the workshop. I met Steve. Steve and I have a long, although rarely intersectional history in the DOE National Laboratories, where I spent most of my career and Steve spent most of his career. But I met Steve in the context of the activities that he convenes globally around something called transcending incrementalism. If you were to just make up in your own mind what that means, you would probably be right. Let's get past the incremental approaches and move forward much more rapidly. Steve will, as I said, ringlead. He'll introduce our panelists. And I introduce you now to Steve Winston.
Thanks, Betsy. It's great to see you. Hopefully everything is nice and sedate down in Arizona, and I hope the smoke's not too bad. It seems to be coming back here. I'd like to just give you a quick sketch as to what transcending incrementalism is all about. Research is, by its very nature, somewhat incremental. The challenges, though, that we face in this century are compound challenges. They're comprised of population growth, which, notwithstanding the fact that some people are asserting that we're going to see the population around the world level off, it hasn't yet. And some of the key areas where population is not leveled off are those in which the struggle to reach economic parity are the greatest. Africa is an example where the population is growing the fastest, and the degree to which most of the countries in Africa are below the parity with the rest of the world are fairly significant. The consequence of that is that you compound those two things, and you end up not with geometric growth, which is what comes from population, but the linear effect on top of that creates exponential growth in the demand curves. And those demand curves affect all kinds of things, not the least of which is the impact upon the environment and the climate in particular. Now, how does that relate to COVID-19? Well, it's actually very significant, because every 1/10 of a degree that is added to the average temperature of the climate accelerates the rate at which mutation occurs in different generations of different types of viruses and bacteria by a significant amount. It's estimated between 50% and 100% for every 1/10 of a degree. And we've seen it, I think, Jim, you can validate this, but I believe we've seen in the last 10 years an average increase of about 3% or 3 degrees overall. I think that's close to right. That's very, very significant. This particular summer is the second highest temperature on record. It's not surprising that we would see the evolution of zoonotic disease and crossover into the mainstream. So a couple of things that I'd like to emphasize. The speakers today are going to talk about a variety of the tangible effects on the built environment. We will cover those. Esther is going to talk about the human impacts and the degrees to which that is very significant. I've asked a graduate student from Texas A&M, Begonia, she gave a very nice summary of some of the things that she's observed internationally. She's originally from Spain. And she mentioned to me what's going on at Texas A&M in the student population, but also what's going on in her own personal life. Her grandfather just passed away from COVID-19 in Spain, where she's originally from. One of the things that she observed is in the last 2 weeks of his life, he didn't get to interact with his family at all and only saw the doctors perhaps a couple of times. And one of the things that I believe that Esther is going to emphasize is the degree to which human factors can impact our ability to survive and strive. So I thought that was particularly poignant, and I appreciate Begonia for joining us today. Also, she made the observation that in the context of Tony's presentation, which she heard on our Thursday meetings, that the degree to which information is shared is really, really important for us to be able to make the case for suspending the individual rights that we would like to assert. That is, not to wear a mask and to go wherever, whenever we want to, and the constitutional provisions for protecting the population. The third thing that she mentioned, and I think it was really, really interesting, and I'll allow her to articulate this in her own way, in her own words, but she pointed out that misinformation is endemic on college campuses, and unfortunately that misinformation is equally credible with the information that we have that we believe is sound from a scientific perspective. And that's really, really unfortunate, because we've got a whole generation of students who's suspicious of the information that we provide from the scientific community. That's not good. So coming back to transcending incrementalism, we're looking at these incremental advances across the board, and we're saying, how do we combine them? Not just from a scientific perspective, but how do we reach across and include the societal impacts and the information that we have? And that extends to 6 different pillars. One of them is preparation. That's something that we didn't do very well. The second one is identifying early emergence. That's a Sentinel program. A third one has to do with the built environment, which is what we're talking about today, and how that will be changing and how it is changing. A fourth one has to do what are the consequential, collateral, and concomitant effects of exposure to viruses. I don't know how many of you ever saw the movie Awakenings. It's based on a book by Oliver Sacks, and it talks about the consequential effects of exposure to encephalitis lethargica after the 1918 pandemic, which was incorrectly called the Spanish flu. And that has its own crazy origins in terms of names, but it also has to do with misinformation, which we're seeing an awful lot of today. One of the consequential effects was an extreme form of catatonia that Oliver Sacks was able to relieve with L-DOPA, but only temporarily. We're going to be modeling at the University of Arizona the various organs that are potentially impacted by the exposure to this virus, which is extremely complex. And that team will be led by University of Arizona, Janko Nikolic will be leading that, working with Betsy and for Betsy on that. Betsy and Bobby will be leading that directly and personally. The other 2 things have to do with dendritic learning and the fact that what's been exposed from this shutdown of the everything is that we have woefully poor remote learning capabilities. We have video games that are far superior to the means by which we deliver information to our grade school children, our high school children, and our college students. And we need to do better, and we can. And the final thing has to do with the ability to control inflation when huge amounts of stimulus dollars are poured into the economy without a corresponding increase in the gross domestic product or even the gross global product. So what we do is, in transcending incrementalism, is we stitch together all these incremental pieces to make transcendent leaps. And we try to move on beyond those natural progressions to leapfrog the things that maybe stand in our way as barriers. So with that, I guess, and Betsy, you can tell me what's next on the agenda, but I believe I'm supposed to introduce Esther. Is that correct?
Yes, sir.
Okay, thank you. And I apologize for not being well versed in what the progression is, but Esther has spent a lot of time and effort studying the degree to which medical effects and medical consequences are mediated by attitude and the ways in which people are able to deal with their stresses and carry forward. So Dr. Sternberg has worked a long time at the University of Arizona, and she's a noted speaker in this very specific area. I think it's really important to take into consideration what Begonia's observations were, and Begonia is listening in as we speak. So Esther, hopefully you can give some insight into how perhaps it might have helped her grandfather persist and survive had he had the opportunity to have a little more human interaction. Esther?
Well, thank you very much, Steve. I'm going to share my screen. And I will start with the first slide. So I'm a physician, researcher. I spent 26 years at the National Institutes of Health studying the connection between the brain and the immune system. And 20 years ago, started working with the US General Services Administration to measure the impact of the built environment on health, well-being, and performance using wearable devices for measuring the environmental factors as well as human factors. And we continued this work through my time at the University of Arizona, which is for the last 8 years. And the culmination of that work is what we're going to present today. My team members on this project, Drs. Bo Yang and Shizhan Li, Dr. Altaf Engineer, Dr. Philip Stoker, who's not here on this presentation, and Dr. Young-Jun Sun, are all, as you've heard, we are multidisciplinary, multi-college, and I'll be introducing each of the speakers as we move forward through the presentation. The part of the introduction that Steve made and that resonated with us and with what I'm about to present is the issue that it's in focus groups actually here at the University of Arizona. One of our communications professors, Steve Rains, found exactly the same thing that Begonia noticed on her own, which is that students are need some kind of risk management, risk assessment tool. And that's exactly what we've developed here. We're calling it Dash Safe. It is a multimodal GIS based, GIS is Geographic Information Systems, real-time COVID risk assessment, management, and navigation tool. And in the spirit of public information, we believe that having this health information in real time will have a number of different impacts. It will help people to navigate the environment and avoid risk. It will help people reduce their stress because uncertainty and lack of information causes stress. And we hope that it will help to counter this disinformation that is rampant. One of the former Surgeon Generals that I worked with at the National Institutes of Health, Antonia Novella, she was actually the first woman Surgeon General, used to say that public information is public health. And that's what this is really about. So this is a dashboard, and Drs. Bo Yang and Shizhan Li are going to describe it in a little bit more detail, but it consists of several layers. There's a master Dash Safe perceived risk dashboard, and we'll show you a picture of that prototype soon. The top several layers consist of subjective sampling based on psychological sampling of perceived risk. So there are different ways of sampling experience. There's event contingent, there's location contingent, and then there's time contingent, which we're not doing here. But we will have event contingent sampling, which we'll show you in a moment, the survey that we're going to be using, as well as location contingent sampling. So that those top three pink layers will give a subjective feeling of people on campus of whether they feel safe or at risk. The next layer, building operations and design risk score. In the interest of time, we're not going to talk about it, but Altaf Engineer and Philip Stoker are working on this piece. That will be an objective measure of risk. And then Dr. San Young-Jun and his team have developed predictive modeling of movement through campus, and he'll be showing more about that. We will not show the navigation tool, but that ultimately is where we hope to go. And ultimately, and eventually, we hope to also link health tracking apps, dashboards with actual health information to this dashboard. So I'll show you the survey for the event contingent sampling. And basically what's going to happen is, this is a research study, so people will be guided to a consent form, which they'll sign. And once they sign the consent form, they'll be asked to fill out this survey, which tells what they are on campus, what they do, and whether they feel safe, neutral, or unsafe, relating to physical distancing, facial coverings, and also what is their stress level in relation to this. Now, we know that different people have different levels of risk perception, and part of the research study is going to address, try to understand that. So this is an example of what the DashSafe master dashboard will look like on a personal computer screen and on a mobile phone. And this is an interactive GIS map of the entire campus. And these little dots here are dots which reflect an individual that has either said they feel at risk, which is red, or they feel safe, which is green. And then the person will be able to look at the percent of people feeling safe or at risk or neutral in a given location. They'll also be able to score the dashboard as to whether it reduces their stress, much like you do on Yelp or Amazon. I'm going to turn it over to Drs. Bo Yang and Shizhuan Li. Bo Yang is a professor at the College of Architecture, Planning, and Landscape Architecture with expertise in landscape architecture and planning. And Dr. Shizhuan Li is an associate professor at the College of Architecture, Planning, and Landscape Architecture and expert in planning. And really, Bo and Shizhuan are leading the development of this master dashboard. So I'm going to run the video of this, what it's going to look like on the mobile phone, and Bo will describe to you what you're seeing. Bo?
Yes, thank you, Hester. Thank you. Please. So this is the IRB consent form. And it'll take a few seconds for you to answer the questions Esther just showed. Either safe or unsafe or medium. And then you can navigate through the campus map or just choose your device location. Once you click submit, you can see the results instantly on the dashboard. If you hover around the pie chart, you can see the percentage people feeling safe or unsafe. And also the map shows you where the risky area or the safer areas are on campus. That's it. Thank you.
Thank you very much, Bo. I want to emphasize that we spend a lot of time with social scientists and the head of the IRB, the Institutional Review Board, to be sure that these questions show what people feel themselves, and that people will not become informants on others. They will not be reporting on others. It's really a a feeling of how people feel safe or at risk. Oops. So the, sorry. The next layer is building operations, which, as I said, we'll skip over in the interest of time, but Althoff Engineer will be able to answer questions in the breakout. Althoff Engineer is our lead at the College of Engineering, College of Architecture, Planning, and Landscape Architecture for Health and the Built Environment. The predictive modeling piece is a very important piece, which Dr. Sanyang Jun and his team at the College of Engineering. Dr. Sanyang Jun is head of Systems and Industrial Engineering at the College of Engineering, and his team, Sarang Jain, Bitjoy Chowdhury, Tariq Islam, and EJ Chen, have been working on predictive modeling of various spaces, indoors and out, at the University of Arizona. I'm going to, this shows the two of the spaces, and Dr. San is going to do a demo, and I'm going to stop share my screen so that Dr. San can share his to do the demo.
Thank you, Esther. So I'm going to play the simulation demo. So I'm running the simulation. This is one of the theater style classroom. As you see, 7:50 in the morning. So students are entering the classroom by following the physical distancing. You see the circle, that's actually the physical distancing. And I actually skipped the class. Now class ended. And then now students are exiting the classroom, and we can collect all the necessary statistics, such as how many contacts, how much time that the students have like a contact time within 3 feet and 6 feet. My second demo that I will quickly show is, so this is a campus-wide like a model. This is the GIS, and it has a lot of the academic buildings, and it has a number of the dormitory, and it has a food court in the student union. And it's actually the 7 o'clock in the morning, so a lot of students going to the classroom. And then I'm actually actually fast forward the simulation, and as you see, depending on the occupancy level, the bubble size changes, and depending on the percentage of the occupancy, if it's above 50%, it becomes the pink colors and so on. Okay, that was very quick.
Thank
demo,
you.
And I'm gonna stop sharing, Esther.
Great, and I'll share again. So thank you, San, for that. So you can see with the various layers that we will have, as I mentioned, subjective perceptions of safety and risk, as well as subjective perceptions of individual stress, objective building information, and objective predictive modeling based on the known class schedules that exist. And we believe that having this tool, which is a real-time tool that people on the campus can link into, will help reduce stress for campus occupants by providing real-time, real information. It will help facilities management personnel implement risk mitigation procedures to correct any risks that have been noted. And it'll help people navigate safely through campus. It will decrease viral transmission by providing this information, and it will help us return campus life to normal. It can be applied to any campus setting in industrial or office parks, malls, urban areas, senior living communities, theme parks, and so on. So we believe that it will have really pretty wide applicability. And you can see that you've heard just the tip of the iceberg of the members of the team. It's a very multi-college, multidisciplinary team. I'm not going to go through all the names here, but Dr. Matthias Mell, who's a professor of psychology in the College of Science, has been instrumental in helping us, really giving me a Psychology 101 training on different kinds of experience sampling. We'll have an evaluation team led by Tracy Crane, Rebecca Blackston, and Steve Rains. And as I mentioned, Marriott Marsh, who's the head of the Institutional Review Board, has advised us on research ethics and quality of our survey. And I think with that, we will end our presentation, and I hope that we stayed within our time. Thank you.
Thank you, Esther. I'm going to move on quickly. Dr. Ian Pepper will be giving a presentation on, I thought, a very interesting quote that I heard you make on national TV, "Poop don't lie." I presume that that's a paraphrase. Dr. Pepper is an environmental biologist, and he's been doing early sampling of wastewater, which gives a strong indication of the presence of the virus before it is ever manifest in the form of symptoms. So Dr. Pepper.
Well, good morning, everyone. WEST is a mixture of microbiologists and engineers that look at all aspects of the water-energy nexus. And the microbiologists have been particularly focused on microbial pathogens, including bacteria, virus, and protozoan parasites. So in the past, we originally worked on the SARS virus back in 2009, and a few years ago, we worked on the Ebola issue. So we have then a long history of working with viruses, and now we're interested in been working with what's now called wastewater-based epidemiology, evaluating the presence of the coronavirus. So the concept of WBE, as it's now called, is very simple. You test the wastewater from a given community, and you ask the question, is the virus in that defined community? Because if it is, the infected individuals will shed the virus into the wastewater, and as mentioned, poop doesn't lie. Also, if the answer is yes, the virus is there, the concentration of the virus gives an indication of the severity of the outbreak. Now, there are several advantages to wastewater-based epidemiology. One is that one test monitors the given community, which can be as large as the surface area of a wastewater treatment plant. So in the case of Agua Nueva here in Tucson, that's 350,000 people, or it can be smaller, as in the case of the community within a student dorm. And I'll talk about both of these instances. So wastewater-based epidemiology has several advantages. It's very sensitive. It was shown in Europe over 2 decades ago with poliovirus that it can detect one infection in 10,000. One test, you monitor the whole community. And most importantly, the virus concentration is a reflection of the total virus load in the community. So this includes infected individuals with or without symptoms. So we do pick up the asymptomatics. Finally, and most importantly, wastewater-based epidemiology is a leading indicator. When people become infected with the virus, they almost immediately start shedding the virus prior to visible symptoms, perhaps 7 days prior to visible symptoms. So this gives you then 7 precious days for intervention strategies or testing the community. So this technique then, or technology, is very useful for detecting the onset of an outbreak. So we began conducting wastewater-based epidemiology back in early March, right at the start of the pandemic, wherein we were taking samples from wastewater treatment plants from all over the country, including New York, Los Angeles, Seattle, and even Canada. And we soon realized that this wastewater-based epidemiology is extremely sensitive. So for example, when the shutdown order began in Arizona in beginning of April, you could clearly see the virus concentrations decreasing 1 to 2 weeks later. And when the opening up order happened a couple of months later, you could see the concentrations of the virus increase in the wastewater, followed by the large increase in cases that we saw. Another interesting aspect is that we noticed that after each of the 3 major holidays this year, Memorial Day, Independence Day, and Labor Day, about 1 week after that, the virus concentrations increased, and 2 weeks after the holiday, of course, the number of cases increased. So this is just an example of how this WBE is very sensitive. So all this work with the wastewater samples from across the country prepared us for the campus re-entry for the fall semester at the U of A. I was asked to lead the subgroup number 3, wastewater-based epidemiology. And my task was to monitor student dorms to evaluate student health with respect to coronavirus. So we began testing about 13 dorms twice a week. And lo and behold, in the first week of classes, I think it was August 26th, we got a positive in Likens Hall. This led to a lot of frenetic activity, a call at 11 o'clock that evening with the president and Rich Carmona and the task force. And the decision was made then to go in and test all the students in the dorm that tested positive. So this was done. 2 students were identified as being infected. They were in fact asymptomatic. They were removed from the dorm, and lo and behold, the next day the wastewater went negative. So this attracted a lot of media attention. And since then, we've repeated this same experience on at least 8 to 10 times, wherein there's a correlation between virus in the wastewater and infected individuals. So wastewater-based epidemiology then allows you to target the testing that you're doing for the students. Since then, we've also realized that the data from the dorms is a goldmine of data, in that you have defined communities within the dorm. You know who those residents are. You know they were all tested negative before they were allowed to enter the dorm. And upon testing everyone in the dorm, you now know the number of symptomatic and asymptomatic cases. So we've been modeling that data, and there's an equation you can use that predicts the total number of infections in a community based on the number of people, the estimated amount of feces using an average value, the flow rate, some other parameters, and the shedding rate. The great unknown there is the shedding rate, but because in the dorms we know the community and we know the number of infected people, we can then back calculate the shedding rate. And we found that to be right around 10 to the 7 per gram of feces. So now, when we go to the wastewater treatment samples from the virus community, from the virus concentration, we can estimate the total number of cases in that community. And if you know the number of reported cases, by difference, you can quantify the number of asymptomatic cases. So we're learning a lot about wastewater-based epidemiology. It's a young discipline. One of the latest examples, we're working with Paul Brierley at the UMA Center of Excellence for Desert Agriculture, and they are interested in having migrant farm workers tested in October. So we're helping them use WBE to test the porta potties. So this is all very exciting. I think the task for the people on the call here today is to think perhaps in the future, how would you design buildings to help wastewater-based epidemiology, particularly high occupancy buildings? Are there ways to compartmentalize different sections of the building so that if you get a positive in the building, you wouldn't necessarily have to test everyone in that building? So with that, I will close.
Thank you, Dr. Pepper. I think that's really interesting and exciting. I'm looking forward to our discussions. Next presentation will be by Matt Bumla. Matt is from Global IFS. One of the key things for us to look at here is how do we make the built environment safe for occupancy and the air we share. Matt?
Yeah, thanks, Steve. I'm going to share my screen so we can all look at it. We can talk through that. So, thanks for that introduction, Steve. So essentially, we're talking about pandemic resilience, and I would like to thank University of Arizona and Restruct, for putting this symposium together. I think it's been enlightening already, hearing the other two panelists and teams present and getting their perspective as well. What I wanted to share was, in terms of a built environment, as we build these buildings that get occupied, in terms of an office space or other type of use that they've been built with, it brings a unique challenge to us where previously the thought process has been to design these buildings to provide comfort and good IAQ. But going forward, obviously, the focus, will be towards, ensuring pandemic resilience and minimizing the effect of a built environment in terms of, an occupant's risk, towards getting infected. So, in terms of who I am, Matt Bumbla, I've been working with Global IFS for almost a year now. I've been in the HVAC industry for 17 years. Essentially at Global IFS, we do integrated flooring solutions, which includes, providing solutions that enhance both flexibility and cleaner air being delivered into the occupied space. Over the 17 years that I've been in the HVAC industry, a large focus has been on the air distribution side. And like any other system, it's more about the delivered value with that system that drives the business for that particular system. In terms of air distribution systems, again, space, comfort, and the type of indoor air quality that we could deliver with these systems has been a large focus of, where I have spent my time. There's a lot of research that I've been involved with, with air distribution systems and their effect on indoor air quality and occupant comfort. So the next 10 minutes, I wanted to just spend, that time talking about a little bit about the pathogens and the mode of transportation. I'm sure you guys have seen a lot of information out there. I just wanted to provide or spend 2 minutes providing a little bit of a context on, why we're talking about air distribution systems here and how they're relevant. And then we'll dive into air distribution systems, various different types. What is the industry recommending in terms of air distribution systems and their effect on pandemic resilience. And then we'll talk about, some future research that I think, we need to take on to collect more data and be a little more informed on the effect of these systems. So again, you guys may have seen a version of this render that I have up on the screen. They've been flashed on news media outlets all over the country. And essentially what it's communicating is how typically pathogens or virus particles are introduced into our environments, whether it's outside or indoor. What we're trying to show here is as an infected person exhales, sneezes, or coughs, they essentially introduce these pathogens into the environment around us, and other people can get infected by getting exposed to these pathogens. What are some of the commonly understood modes of transportation? There's three broad, categories that they're divided into. Two of the ones that have gotten the largest exposure in media and in research documentation have been droplet and contact-based contamination. Essentially what this is as someone exhales these pathogens, you could be really close to that person and breathe the droplets in or get in contact of those. That's how you could get infected. Or you could be touching contaminated areas, which again, if you end up touching your face or finding a way of getting those pathogens inside your body, you can get infected, that way as well. And this is where some of the strategies and the mitigations have come from, which is again, the most common ones that we've talked about is social distancing, washing our hands, and using masks. All of these strategies go towards addressing those two commonly understood modes of transportation with these viruses. One of the key aspects or mode of transportation is also airborne, which hasn't got as much press, for multiple different reasons. Some of those have been, there was some research that was being conducted to understood, how much of an effect that was having. And CDC and other organizations, were kind of holding off on, kind of sharing that is, a way of infecting people, and it is actually making a difference out there. So I was looking at the updates on CDC's website. I think 2 days ago, their new update on how the virus gets transmitted, they've actually acknowledged that airborne transmission is definitely one of the ways. And the way it happens is, again, as you cough, sneeze, or exhale, you're not just creating droplets, that, end up dropping on surfaces. You could create aerosols or airborne droplets as well that stay afloat in the air, and they could travel with the air, and someone else can breathe enough of a dose, further away from where the infected person is to get themselves infected. And again, a lot of research has gone into this topic, and it's accepted a lot more widely now. So I'm not going to spend too much time sharing that research or that information. I think it's out there, and we can talk more about that in our breakout sessions as well. The point here is, in terms of a built environment, what can we do within a built environment to not just minimize our exposure with droplets and contacts, but with exposure towards an airborne or aerosol type contamination as well. So, this brings us to air distribution systems, because again, that is what's being used to condition our buildings. For someone that might not have been exposed to these types of systems, essentially any built environment, especially in US and Canada, they have some sort of an air distribution system. What is an air distribution system? An air distribution system is part of the HVAC system that keeps our building comfortable. An air distribution system is referred to as a distribution of air to and from a conditioned space to, again, keep it under temperature control. Typical goal of an air distribution system, again, is to introduce the air into the space. This is conditioned air that's introduced into the space, and it will take care of, different heat loads or cooling loads within the space itself, which could be, computers, equipment, occupants, it could be sun that might be beating down into this room. Again, all of those heat gain and heat losses have to be taken care of. And air distribution systems are the ones that bring conditioned air into the space to take care of all those loads within the space itself. What are the different types of air distribution systems? There's two broad categories. There's multiple different variants for each one of these categories, but two broad categories are mixed air systems and stratified air systems. So we'll start with mixed air systems. These are the systems that are being more commonly used in buildings. Chances are you've been exposed to these type of a system in your existing built environment. And essentially the way it works is you would typically have a ceiling diffuser or an air outlet at the high level, which will bring in air at high velocity. And then essentially that high velocity air will, the goal of that air will be to blow the air around the space and circulate it within the space to create a mixed environment. So if your goal is to provide 75 degrees, let's say a typical set point for an occupied space, you would introduce the air at 55 degrees, and the goal is to, again, push the air at high velocity outside of this diffuser and then circulate that air within the occupied space to provide a mixed air environment. And essentially, again, the goal here is to provide homogeneous mixed environment. These are the systems that have been around for decades. In fact, you could go as back as buildings built before World War II that started to put these types of systems in, and it still happens to be the most commonly used air distribution system that we're exposed to. So that's a mixed air system. Now looking at stratified air systems. The stratified air systems, it's really not a novel concept. It's been around for 25, 30 years. And essentially what these systems do is, basically work exactly the opposite of a mixed air system. So instead of introducing the air at the high level, now you're introducing the air at the low level. And the key difference here is that you introduce the air at low velocity. So again, as I was showing in the previous render here, you were introducing the air at high velocity, at high level, and mixing the space itself. With these systems, what you would do is you would introduce the air at low level and pull that air onto the floor, introduce it right next to the occupant. And essentially the idea is to promote stratification instead of mixing. What does stratification mean? Stratification is essentially a stratification of temperature and contaminants within the occupied space. So introduce the air at the low level, there's a heat source in the space that will seep that air towards it, and then essentially you would condition that occupant by introducing that fresh air or conditioned air right next to them. To give you guys an idea on how the concept works, let me just show you a quick video. What we're trying to show here is, what you see here is essentially 3 different load sources within the space, and they kind of represent a typical occupant. There's heat generating light bulbs within these heat sources. And then what you'll see is that the air is being introduced at low velocity through this low level diffuser, and we'll see how the air distribution works. Okay. So yeah, that's essentially your low velocity air being introduced into the space. It'll cool on the floor. You can have these diffusers on the floor as well. We'll do the same thing. But what you notice is as this pool of cold conditioned air hits the heat source, there's heat plumes that you could now see are drawing this cold air over the heat source and conditioning the space and the heat sources accordingly. So you can imagine that's the clear difference between how traditionally with a high velocity jet that's mixing the air in the space versus doing it this way, where again, each heat source kind of drives that pool of conditioned clean air towards it to condition itself and to keep the space comfortable.
Okay, and
That's
Matt,
essentially, yeah.
hopefully you can finish up fairly quickly.
I can, yes, yeah, I can try and wrap up this quick. So to give things, put things into perspective in terms of what does that mean for air change effectiveness. Air change effectiveness is age of air in the breathing zone versus at the return grill level, which is up at the higher level. With a mixed air system, you can imagine a perfectly designed mixed system will have the same amount of contaminants in the breathing zone versus at the return grill, which is what this research has shown that at best you'll get close to 1. Whereas with a stratified air system, which is listed as a displacement ventilation system here, at the heat source, you would have close to half the amount of contaminants than you would at the return grill level. Obviously the industry and the organizations are looking into what needs to be done to re-enter into our occupied spaces. But what's happening is, we're talking more about dilution and capture and kill, which essentially is bring more outside air and filtration, which obviously all of that is going to help and is required. But, what really needs to be looked at is the air distribution system type as well, because, they can obviously make a difference in terms of reducing the exposure to the pathogens. To give you guys an idea, I'll just run a quick 1-minute video so you can see what it looks like when you're using a mixed air system instead of a stratified air system. So the point I wanted to make here was, and this image does a good job, is there's an overhead mixed air system with grills and diffusers supplying high velocity air at high level. And then there's returns that are shown in these larger rectangles. Essentially what happens is as the pathogens were gotten introduced, that high velocity air jet picked up those pathogens and took them as far as 50 feet away to infect people 50 feet away, which is what's happening in most of our buildings. And that's one of the big reasons why we need to talk about that as well, instead of just talking about returning the air and filtering it, because by that time it's already too late, because people might have already been infected within the occupied space. So I'll try and wrap up here. Essentially, the point I wanted to make was the type of air distribution system matters, and if there was ever a time to prioritize space air distribution, it's today. And that's where we feel there's a lot of research out there that compares these types of systems, but I think further research is needed to be able to quantify a clear difference in terms of infection risk reduction with one system versus other. So again, organizations can start using them and getting them specified accordingly. But sorry for going over there, Steve. I'll turn it back to you now.
No problem, Matt. I'm very interested. We're going to have a lot of discussion about this because it has a lot of significance to the overall. Let me introduce Professor Macero. She's written a very insightful essay on the Constitution and the degree to which the Constitution actually protects us. One of her, I think, derivative quotes is that the Constitution is not a suicide pact. With that, Tony, fire away.
Thank you. The paper was written with Dr. Marvin Slepian and a colleague of mine, Justin Bedot, at the law school. and it's in response to pandemic public health measures that are being imposed. People think, my rights, I shouldn't have to do this. There's terrible disunity in the country right now. So the first question we're asked is, why do you think that we can vault the disunity? And we say, we won't completely. We're not naive. We know that the situation's tough in terms of arriving at consensus. But we make an effort in the paper to show that consensus does exist about key points that should be leveraged by people interested in imposing pandemic public health measures for the good of all. One is, and it's in service of the following obvious point: we have to go forward, and cooperation is going to be essential to that. Some people never got to leave the workplaces. They're there now and have been throughout the pandemic. So there's no blinking in the face of that reality. And so this paper is an attempt to do what we can to create a conversation accessible to non-lawyers about a consensus that we think exists. First of all, it's really clear we have this common need. Everybody wants to safely get back to our families, to our jobs, to the workplace, to our places of assembly, places of worship, places we used to go to eat, to parks, all of that. These are what make up human lives, and without those places, we suffer, full stop. And we've lost really important moments of connection, and some of us have lost loved ones, some to COVID itself, others during COVID have lost and been unable to be there and to grieve together. These are really grave consequences for all of us that have a psychological dimension to them, of course, as has been already covered. So these are things that we have in common, and that ought to be part of the conversation. We all want to go back, and we want to go back as safely as we can. We all value life, our own, and each other's. But beyond that, the paper's principal intervention is to say we share some norms that are derived from or reflected in the United States Constitution. And here they are: rationality, process, liberty, and equality. There's a technical way of talking about these. I'm going to talk about them in a non-technical way, but basically they derive from due process and equal protection. Number one, rationality matters. What does that mean? Return conditions have to be based on the best available research and knowledge about this virus, which seeks a host. It can't live without one, and its risks. So a science-forward approach makes sense constitutionally as a matter of the norms that we share, even where the Constitution doesn't apply. Facts matter. And a point worth making is the Constitution does apply to the U of A because it's a public institution. Private institutions aren't directly held by the Constitution in the way that we are, but the norms still hold. So the conversation matters in whether you're a private entity imposing these limits or a public entity. Bottom line, policy planners are going to need to have someone like a Dr. Fauci help them shape, explain to the public what they're doing and why the policy's sound. But they're also going to need engineers, people who know about air quality, what we've been hearing about here, transmission. All of this is going to matter so that we can build the most rational, in a due process sense, but more generically, sound pandemic policy that we can. Facts matter. Second, and this is critical, and sometimes planners neglect this, process matters. People care about process. They have expectations. Return conditions can impose restrictions that are unpleasant. Not all of them are, but some of them are unpleasant. And it ranges from I have to wear a mask to I might need a vaccine or something that's a greater imposition, or I might have to quarantine. People have a right to expect that these restrictions are not only well-based in science, but are accompanied by procedures that give them notice of the requirements and voice, a meaningful opportunity to be heard about them. Planners who neglect the process step will find non-compliance and resistance and fears mounting. And people want to be heard as individually as they can, where it's feasible, and it isn't always, to individualize this notice and opportunity to be heard opportunity. It's a cost worth incurring. To individualize them, to give people that kind of feedback opportunity, and also engaging in a feedback loop may enable the planners to anticipate problems of application that they wouldn't otherwise see, so you get better policies if you have that feedback loop. It also should include an opportunity for people, within reason again, to object you're applying this rule to me and you shouldn't. I should get an opportunity to be heard to explain why that particular rule should not apply to me. So facts matter and process matters. And the greater the restrictions, the more both matter. Third, and you've been hearing a lot about this, liberty matters. We care about, Americans, not exclusively, but of course we care about liberties, especially ones we regard as fundamental. Think freedom of religion, freedom of speech, freedom to travel. All of these things are in our core, in our person, whether or not we can articulate the specific line in the Constitution that arguably is the source of that right. So, for example, if contact tracing is essential to effective virus management, and it has been for a long time been used as a tool during pandemics, then those tools ought to protect personal identity as much as they can, while also serving the rational public health end of locating people who might test positive for COVID-19. An aside here is testing waste to determine where the risk is better than other forms of tracing or identifying locations that are problematic because it's not so individualized, and thus the privacy incursion is less. The liberty cost is less. So you need fact sensitivity, process sensitivity, and you need rights sensitivity. Liberty matters, and especially with respect to fundamental rights. Now, what else matters in this situation? Well, when I talk about liberty, it's true. The Constitution is not suspended in emergency. It still pertains. These values still hold. But there's a huge caveat, and Winston's already Mr. Winston has already mentioned it. I wish it were my phrase. It's not. But the court itself has said our Constitution is not a suicide pact. What does that mean? Well, it's just a pithy way of saying you're not alone in your liberty. When you swing your fist and you hit my nose, my rights intrude on your right to just have that nice free access of motion. When you cough, you invade my air. If you own part of the river or a bank on what you put into the river is going to affect me downstream. And all of this has been well known from the founding period. Moreover, the founders were not libertarians. The founders believed in liberty. More practically, they believed in a kind of civic republicanism. That's not libertarianism. That means that when you exist in a society, you give up some of your autonomy in order to have a more robust communal life and care for the other. And this is well established. Well-established law, 1905, US versus Jacobson, mandatory vaccines, smallpox, breakout. The court upholds the right of pandemic health professionals to impose this incursion into people's liberty. And it's carried forward into just this last term where the United States Supreme Court in a 5-4 opinion concluded that a California limit on congregations, religious entities, that the California could limit the attendance at places of worship in ways that they did, as long as what they did was fair as applied to other entities with similar population density parameters. So liberty matters, but it's not exclusive. You have no absolute right to speech. You can't cry fire falsely in a crowded theater, and you don't have an absolute right to not wear a mask or to do any number of things that are being requested of us or required of us in the pandemic. But that's not the end of it. And it took the Civil War to add this to the Constitution: equality matters. And there are two parts about this that the COVID has really laid bare. One is this virus has not had an equal impact on all of us. It's been very unequal. COVID doesn't paint with an even brush. A lot of bad things don't paint with an even brush. Some populations and communities are very much more at risk and very much less able to protect themselves. So an equality-driven policy is one that pay attention to that differential impact. Greater resources should go to those who are most at risk. And that's in that way we better achieve equality. For example, if the major rule is wash your hands often, then you ought to know or ought to ask, is there clean water available? It might be, as the HARI program with which I'm associated and the U of A more generally, it matters to us that over 20% of the Navajo Nation lives without ready access to clean water. So that's a huge disparate impact right there off the top, and not a surprise when you see what happens and with respect to COVID outbreaks on the nation. Other things, though, matter. It's not just the disparate impact, but there's also the more fundamental, treat like cases alike. That's the second way in which equality has to be part of your planning and thought about in advance when pandemic policy planners do their work. The church case that I mentioned, it mattered to the United States Supreme Court, to the majority, that the church's density issues were not being treated differently than other similarly dense places of congregation. So one type of business is allowed to reopen and another's not allowed. The planners have to have a decent rationale for those different rules. And those rules, those differences have to track comparable health risks in those locations rather than some other basis that smacks of political capture rather than fairness. So the paper says, in sum, we agree on a lot. Facts matter, process matters, rights matter, and equality matters. And the last, which was said up top, we say in the paper too, persuasive communication is going to matter. What I'm going to listen to and heed is a 65-year-old law-trained person with certain vulnerabilities to this virus is going to be really different from what my students will find persuasive, and what kinds of maps you communicate to just to the university. Some are going to look at it, some won't. What they're going to apprehend, what they're going to understand is going to be different. Some of my friends think they're virologists. They have big opinions on all of this in ways that may or may not be justified. But we're going to have to think about how we communicate this, building on the ways in which we come together, building on rationality. What won't work, I believe, is trying to shame people into wearing masks. That's only going to cement their resistance and maybe even drive them to socialize more behind closed doors, putting the rest of us at even higher risk. So we have to return. Some of us never left. And if you want some of us to come back, you're going to have to prove to us that you're going to protect us. And we all want to come back. Thanks for giving me the time to raise the con law flag, as I always like to do. Thank you, Steve Winston and Jim Beiser and everybody else associated with this for inviting me.
I guess I have to unmute first. Thanks, Tony. We're going to take a break right now. We'll all return at 10 o'clock Pacific time. And then we're going to have some general discussions. And we'll launch into each of these subjects in some detail. So I'll see you when we get back at 10 o'clock Pacific time. One of the things that I normally do is almost every one of the Transcending Incrementalism meetings I've held, I know most of the folks by name and in person, having had an opportunity to interact with them. And there's lots of folks today that I haven't met before, but what I'd like to do, if we can, and I'll restate this after everybody gets back together, is I'd like to, as people interact, just give a quick a 1-minute sketch of your background and your interests. And I think that would help us all. I'm not sure if everybody knows each other. So I think it's useful for us to share a little bit personally. And maybe, as Esther pointed out, maybe we'll establish a rapport. And that rapport will make us more resilient. So that's a hopeful objective. We've got about 2 minutes before things get started again. Barbara, would you like to say anything about where we need to head?
Well, I think that the only thing I'd like to add is that after this discussion, we'll have a shorter break, and then the connection rooms provide you the opportunity to get together and have further conversations on any of these subjects or extended conversations on other subjects you may be interested in with people that you may have observed talking on this in the symposium. You will be automatically distributed to various connection rooms, breakout rooms, but then you can choose to relocate to any room you choose. So either through the chat or through finding a subject area that you want to join, please feel free to move about the breakout rooms however you want until you find a conversation that you're interested in.
That's great. In fact, one of the things that most of you will have as an advantage over me is that you have probably some level of technical competence. I will probably get lost in the ether somewhere. So if you find me wandering around, please bring me back to some safe haven, and I'll join at that point. The breakout rooms are being illustrated here, so you can kind of see where the connection breakout rooms are. You can choose, as it shows there, how to get there. And one of the technical persons may want to lead you through how this works. If we could take just a second to explain that. Somebody give you a quick view.
I think Barbara had that almost perfect, and there's another slide up explaining it. So to encourage a discussion, you'll be automatically assigned to a room, but you will have the option of switching between rooms, coming back into the main room. That is free, up to you, and the rooms are or will be labeled by our presenters that you have seen so far, so that you can actually engage actively with the past presenters.
And at the very end, for the last few minutes, you'll be brought back into the main room automatically. And Nancy Pollock-Elwin, who's the Dean of our College of Architecture, Planning, and Landscape Architecture, will close out the day for us.
Okay, great. Okay, well, why don't we go ahead and chat a little bit and share some thoughts and observations. Tony had to leave, as did Dr. Pepper, for other things that we needed to do. But Esther in particular, I'd like to explore some of the work that you've done that is beyond what you presented. In particular, the human interaction part of how people become and reach a level of resilience. And I'd like to introduce you to Begonia, who is on our screen. She's the person with whom I shared I think, kind of poignant story about her grandfather. And I'd like to begin with that, Esther, if you don't mind. I think you're on mute, Esther.
Sorry. So thank you for that introduction. And I was saying that my heart goes out to you, Begonia, for this difficult situation. I can't think of anything worse than to not be able to be with a loved one at that moment in their lives and in yours. So my heart goes out to you. There is no question that social isolation it causes stress and is bad for your health. John Cacioppo, who sadly died a couple of years ago, was a real pioneer in this domain. He wrote a book called Loneliness, and I would recommend that to anybody who's interested in this topic. It's a particular issue amongst the elderly in general. Kathy Insel is on the line, I see, and she's professor at the College of Nursing and has expertise in this area in the elderly. And maybe Kathy would want to comment later on this, but there's no question that social isolation does cause stress. Chronic stress causes increased severity and frequency of viral infections, decreased vaccine take rate, speeding of chromosomal aging, speeding of cancer growth, and slowing of wound healing, all because of the stress hormones and nerve chemicals that are released when one is stressed. There's a huge literature on this subject. Jan Kiko Glaser, Ron Glaser, Sheldon Cohen, and others have shown that chronic stress impairs the body's ability to fight disease in this way. It doesn't cause the virus. Of course, the virus causes the virus, but through the anti-inflammatory hormone cortisol that's released during chronic stress, your immune system's ability to fight disease, to fight the virus, is impaired. Interestingly, Sheldon Cohen, back in 1991, I think it was, published an article in the New England Journal where he looked at the impact of chronic stress on severity of the common cold using 5 different viruses that he exposed people to, and he actually measured, talk about, you know, the poop thing, he measured the weight of the mucus that was coming out of the nose, and one of the viruses that he used was a coronavirus. Not this one, obviously, but something related to it. And there's no question that chronic stress makes these viral infections worse. So it impairs the immune system's ability to do its job. I don't think anybody has specifically compared isolation stress to viral resistance or resilience or lack thereof or susceptibility, but it certainly could contribute. And there's a concept called allostatic load, where, and this was Bruce McEwen, who also sadly died last year, a leader in the stress domain, neuroendocrinology, neuroscience. And he had this concept called allostatic load, where every single small or large stressor to which you're exposed accumulates, and the cumulative effect of those multiple stressors is what affects your body's ability to heal. So I would predict that isolation could contribute to all the other stressors that we're experiencing during the pandemic, which is uncertainty is a huge stressor, job loss, financial loss, we heard about inequality, all these things could contribute. That said, given what we have now, at this moment in time, in terms of the ability to interact virtually. Here we are, we're all interacting virtually. Medical consultations can now occur by telemedicine. If this would have happened 10 or 20 years ago, there would have been extreme isolation. And what we need to do, I think, going forward is find ways to utilize, and one of the speakers mentioned this, or maybe it was you, Steve Winston, utilize these technologies to help reduce isolation to the extent possible. Of course, you can't have the hugs and you can't be there, and touch is a huge, huge way to reduce stress. Touch of a loved one. John Cacioppo also showed this, that the converse of isolation, if you have increased positive social interactions and especially touch, it reduces stress. So we can, to a certain extent, replace some elements of isolation, and we need to work on using this more, but it certainly could contribute.
You mentioned touch, which is, I guess, primarily associated with oxytocin. Is that correct? Then the production of oxytocin.
Oxytocin, yes. Yeah, oxytocin, dopamine, a lot of nerve chemicals. But I don't want to divert from the topic at hand, which is the built environment, and how can we, one of the things that we've been doing with the U.S. General Services Administration and Kevin Kampshire, who's the Director of High Performance Buildings for the federal government through the U.S. General Services Administration, how do we can't remove all stressors. I mean, there's just no way, but every single little stressor that you can remove can help to increase that resilience of your body. And in this context, the built environment is something we have control over. And we have control over elements of the built environment that can stress or elements that can calm. We heard from Matt Bumbla about the ventilation. You know, designing the built environment to reduce stress and to improve health and well-being is really a very important aspect of this. I'm going to ask Altaf Engineer to comment, because that's his domain. He's an assistant professor at the College of Architecture, Planning and Landscape Architecture, and leads the Health and the Built Environment program there.
Thanks, Esther. I think that simply by making the information available to the users and everybody reduces stress a lot, which is what Dash Safe does, basically. It presents standard information in a very legible and available format together in one piece. And simply, so yeah, we do the research, we collect and analyze, but telling our users what we find and how that is useful is really vital. And I think maybe Steve said that earlier, that, you know, how do you bring this together and present this in a way that it's available to people, right? People want to know what's going on. Students want to know what's going on. And that's the comments we've been getting from the students, right? That how can we get access to this? And I think that's what you're trying to do here.
One of the things that's kind of interesting is the degree to which social media is helping to alleviate some of these stresses. But one of the things that is a concern, and it has to do with hormones. Hormones are stressors, and younger people have more stress from their hormones than people my age who don't have much hair left. So
I think I need to, saying hormones is sort of like saying sports.
yeah.
You know, there are many, many, many different kinds of hormones, and some are stress hormones, and some are relaxation hormones, and some are feel-good hormones, and so on. So the trick, I think, that we have, and the challenge, is how do we design the built environment to optimize those feel-good hormones and reduce those stress hormones. And there's a large literature, and so I must say, I didn't mention in my introduction that I'm Director of Research at the Andrew Weil Center for Integrative Medicine here at the University of Arizona in the College of Medicine, and also Director of the Institute on Place, Wellbeing, and Performance that links the Andrew Weil Center for Integrative Medicine, the College of Medicine, the College of Architecture, Planning, and Landscape Architecture, and numerous other colleges that we've mentioned, College of Engineering and College of Science, and so on, in order to figure out how to design the built environment to optimize those feel-good hormones and reduce those stress hormones. And we know that there are many elements of the built environment that can stress and that can calm. What you see and hear and smell and touch and do in a space, in addition to all those things that we heard about of the airflow, the temperature, humidity, and so on, that all can contribute to a person's resilience or not. I don't want to take over this conversation. So Barbara, do you have any other comments? You're on mute now.
Yeah, I know. No, I don't. I think your point is right on. It is. I know we're transcending incrementalism, but when it comes to reducing stress, it tends to be an incremental process. And so we have a broad spectrum of those things that we have to address one by one. There's no panacea here that we can go to. I was really interested in the Dash product, not only because it communicates very quickly it focused on risk, but it communicates quickly, but it also had so many different layers to it. And I know that you were running out of time, and I was wondering if you could talk a little bit more about the different layers of that project and why you chose those layers and why you thought that they were important to people who would be looking at the risk of being in the building.
Well, we wanted to have subjective. So when you're doing a human subject study, when you are trying to help people to improve whatever situation they're in, you want their subjective feelings and you want their objective observations. And this is what we've done, as I said, for decades now with the US General Services Administration. We combine objective measures of health with heart rate variability, so stress measures, sleep quality, physical activity. We're not putting that in this dashboard, but you have to combine them with how people feel. I mean, how people feel is a very important aspect of health. And so the top three layers that I mentioned are how people feel. whether they feel at risk or safe. And obviously different people, different age groups and different risk factors are going to feel differently. And then we have the objective measures. I think I'll ask Sanyang Jun to comment on the predictive modeling, because that's a really important part of this.
Yes, so we are using computer simulation to provide the predictive analysis. So, like based on the people perception of the risk. So, if students want to move from location A to B, one way to do is like I want to go there as fast as possible, or I want to go there. I have plenty of time, so I want to go through at a safe route as possible. And so depending on we can provide a lot of the predictive analysis of the user, actually the interest. And if I want to add about this people perception about the subjective versus objective, I think when we talk about like this, the formite contact or airborne issues or the physical, contact from the droplet, I think as Esther mentioned, the one way, for example, like how crowded each building is. I mean, we can actually put real sensor, and there is a university researcher collecting how crowded each building is. So one way is actually or we can have like a computer video to see how people are wearing masks and whether people are maintaining the social distancing. But that's actually one way. But another way is really based on humans are we are intelligent, so people actually can provide their perception about the safetyness of the building in terms of the social distancing as well as the wearing mask. So.
Yeah, one of the things that I think would be useful for us to discuss, and this is something that Prem brought up in his note, and I wanted to come back to something that Matt said, and it comes back to people's right to have information. At the University of Arizona, there are several different types of buildings. I'm not sure how many of them have stratified air and how many of them have mixed air. Obviously, it would be interesting for students to know which building has which. And my presumption is that they're at greater risk of exposure in the mixed air building than in the stratified air building, or at least that's the perception I have. The other trade-off that Prem brought up is how do we look forward and make sure that we're balancing the questions about the design of a facility to take into consideration things like energy consumption, and balancing that against the exposure to health risks. And then a third thing, which comes back to 1977. And I don't know how many of you remember 1977, but it's emblazoned in my head because that was just yesterday for me. But we built a whole lot of buildings with no windows because we were worshiping the energy crisis, which didn't really turn out to be a crisis after all, but it was one of those temporary things. But people, and particularly high school students and students, got shoved into these buildings with no windows. I can't believe that that's good for them from the perspective of the hormones that actually let you feel like you're in touch with the outside environment. So Matt, coming back to your point about mixed in air and stratified air, it seems to me, and Milana Bookman-Traus will be talking about this tomorrow, there's strategies that we can use that exploit the stratified air that would be foiled entirely by the mixed air. But then there's the question that Prem brings up about how do we balance that in real time and capital investment? So
yeah, absolutely, Steve. Essentially, in terms of a built environment, obviously a whole paradigm of what the goals are is shifting. And I was noticing Prem's comment on the chat as well in terms of not just looking at the now, looking at the near and the long term as well. just like anything else, obviously we're in unprecedented times, and there's a lot of these things we're talking about today. As the vaccine comes out, as we build herd immunity, some of these questions will stick, others will, tend to go away, right? The more important ones will stick, the others will go away, right? So today we're talking about, downsizing, or reducing the occupant density within the buildings and stuff. And some of that may change, down the line. So keeping that now, near, and future in mind, we have to start thinking about, modularizing our systems in our built environment, where again, to some of the points that Esther and the team from DashSafe made as well, obviously you want to do it all the right way and build upon things to provide the right environment where people feel safe, and they feel like they're more in control and they have the knowledge. At the same time, as our thought process evolves, our buildings are able to adapt and are flexible enough to change how they function and operate as well. Like, for example, I can speak, a lot more from the HVAC perspective of things. You could put in systems, where you're totally focused on first cost, but they're so rigid that if you decide to change your occupancy levels, you basically have to gut your system out and almost, replace the whole system if you were to change your expectations. Versus keeping some of those things in mind in terms of, okay, today we're going to 30% occupancy. In a year's time, we see ourselves going back to 60, 70% occupancy. Looking at some of the modular systems which are not as rigid, building some redundancy, some capacity there, to be able to react to those things. And the point about mixed air versus stratified air, that's where that comes in as well. With a mixed air system, you have to mix constantly throughout the space. So if you shift your loads, there's limitations to how you could still condition your space effectively. Whereas just the nature of a stratified air system, where literally the occupant, the heat load, decides how much air or fresh air it gets, they're a lot more forgiving and flexible in that sense as well. So I'm not sure how effectively I've answered Prem's question, but I think, that's kind of the mindset I think we'll have going forward, is more flexibility in planning for future, so your buildings truly can stand the test of time.
Well, and I guess it also comes back to the question of what information do we share with people? For instance, do we share information with people about the types of air systems that we have in different buildings? And if we don't, how do we justify not doing that? And if we do, how do we deal with the unintended consequences? And then it comes back to, how do we inform people as to what the differences are?
So if I might add here that there are a number of standard setting organizations that have been grappling with this from the beginning of the pandemic and before, from when it hit China. So the U.S. Green Building Council that certifies building as LEED. There is a portion of it now called WELL that certifies buildings as healthy. They have a task force, which was co-led, I might add, by Rich Carmona, former Surgeon General, who's leading our reentry piece here at the University of Arizona. The U.S. General Services Administration, ASHRAE, are all grappling with this. How do we balance the sustainability needs and energy expenditures with designing for health? And it's pretty clear that we need to design for health. Altaf Engineer, do you want to comment on this?
It's a big challenge balancing both, because the supply of outside air, people keep asking to increase that in these times. It's not easy to recondition that and then save energy. Really, the costs increased tremendously. Also, the filters. I mean, there's been this recommendation of putting HEPA filters everywhere. And the issue with that is, well, they don't fit in existing systems or in many existing systems. And the second part of that is the system has to work really hard to push air through it. And that tremendously increases energy costs. So, I mean, what we've done in our campus so far is use mode 12 and above standard, which is recommended by ASHRAE, which works with our existing systems. But even that takes up additional energy load. So I'm a big advocate for natural ventilation, though we keep having that argument about, well, if you open a window, you get dust and dirt, and that needs to be filtered, and pollutants inside. But I feel like, there's also the psychological benefit of opening a window in your space and having that available. And sometimes that outweighs the benefit of a little more increased energy. So I think you need to consider all of that together and come up with a solution. Really.
Yeah, one of the things that's kind of interesting, Andrew Barron at Swansea University has developed a method of treating filters that can reduce the delta P across the filter to where a MERV 8 it looks like a MERV 13 in terms of its capture efficiency of viruses, including viruses and bacteria. So we're going to look at demonstrating those at the University of Arizona here in the very near future. There's also, I think, a very good questions that the people have raised about, somebody suggested, should our idea of comfort change? I think that's a great suggestion. I'm not sure how we come to a uniform agreement on how warm or how cold it should be. I know our cars are now designed so the people in the passenger seat can be cooler than the people in the driver's seat, but
so this is one of the issues that, as I said, working with the U.S. General Services Administration and Kevin Kampshire, we've been grappling with, and there's huge variability in individual comfort. Everybody has lived in a home or worked in an office where somebody is always turning the temperature up or down. Has to do with actually sex and gender, hormones, and clothing that we wear, and personal experience and comfort. One of the solutions is individual comfort zones. And maybe Barbara can speak to this, because I don't see Alethea Ida on the screen, but Alethea Ida is one of our associate professors at the College of Architecture, Planning and Landscape Architecture, who is developing individual bio materials for individual temperature and humidity comfort. Can you talk about that, Barbara?
Well, I can't talk about her project, and I would not, and I wouldn't do that to her. But she is going to be one of the panelists tomorrow. So if you can join for the discussion tomorrow, I'm sure she'd be happy to talk about that project. But but this brings up a really important point, and that is, how flexible can we be when we're talking about building systems and pandemics? It's certainly brought to bear the need to be more flexible than we currently are. Our old systems in older buildings are not flexible enough to bring in sufficient outside air, to adjust to filter size, to change the airflow within the buildings. There's so many issues that they cannot address. And we do know that buildings, that this goes to the equity issue in a very big way, as Pam brought up in the chat. Older buildings serving some of our poorer communities are going to be the last to be adjusted for this. So creating systems or portable devices that could address the quality of air in your immediate personal space could be an idea that addresses short-term needs. As in a flexible short-term way, without having to address an entire building system. But in the long term, as Prem is talking about, we need to look at all the constraints, including energy, to allow us greater flexibility in design, so we have more levers to pull when we're facing challenges like this.
Yeah, with a few minutes left on our discussion time, I guess we're going for another 30 minutes. Is that right, Barbara?
Mm-hmm. Yes.
I'd like to bring in Ian, who's returned, and talk a little bit about, we've been talking about the airflow systems, but there's also the plumbing. And Ian, I recognize that it's not simply something where you stick in a transducer in somebody's toilet and then can measure what their individual output is with respect to viruses. and you might discover other things that they don't want you to know. To what extent can we segregate or divide up the community, particularly within a dormitory, to more discreetly measure, and I guess discrete in both senses of the word, the degree to which people may be exposed to viruses without knowing it? Ian, you're on mute.
Where am I? I'm unmuted now, right?
Yes, I unmuted you.
Thank you. Wastewater-based epidemiology, again, is a young discipline, even though it's been around for 20 years. So I think you're going to see some significant changes in the near future as to how we do things. And WBE could be used, for example, to monitor high-risk buildings, prisons, nursing homes, situations like that. I think there are ways, as I mentioned, to compartmentalize high occupancy buildings so that you can perhaps develop strategies with pooled sampling for viruses. But let me also mention that there's some other ways that wastewater-based epidemiology may be used in the future. I've been asked by Princeton University to lead a U of A effort or have the U of A be a site for an NSF Engineering Research Center. We're at the very early stages. The proposal is going to be due in about 2 weeks. If we're fortunate enough to get that, to make the first cut, then there'll be a lot of opportunity to develop some new ideas. So the title of this thing is NSF Engineering Research Center for Convergent Engineering Towards Healthy, Sustainable, and Equitable Post-COVID Cities. So really what it means is innovative engineering in cities after COVID. And there are some interesting ideas. So for example, we can do shotgun viral genomics, wherein we can look for novel viruses that may be coming down the pike. You can look at food metabolites and look at the influence of food insecurity. So a lot of really exciting things on the horizon. You probably know that wastewater-based epidemiology up at that other institution, ASU, Ralph Halden was actually using it to look at incidents of illegal drugs in wastewater, and from that estimate community use of those illicit drugs. So there's a lot of things potentially coming down the pipe. Technology companies are beside themselves in a hurry to develop new kits to speed up the processing of the sampling of wastewater. At the moment, you got to get the sample from a manhole, get it back to the lab. You got to do sample prep, which involves filtration and centrifugations. You got to do nucleic acid extraction. Then you got to do reverse transcriptase PCR. Then you got to do qPCR. So there's a lot of moving parts there and a lot of opportunities, I think, to develop new innovations to streamline this process.
Now, is there a possibility that by sampling, and I guess if you were doing individual sampling, that could in fact become a stressor? Because some people de-stress by investing in their own.
I agree with you there. I mean, like Kelly Reynolds is working on an immunoassay microfluidic smartphone technology. It's almost like a dipstick approach. And I could see, you could use that in your own personal toilet, but I agree with you in that may be too much information. I worry about, this thing they're flogging now on the market of a little heart monitor thing where you can monitor your heart. Well, man, that's going to drive you neurotic in a heartbeat, I would think.
In a heartbeat, literally.
Well, once again, different people have different tolerance. And, when we studied over 270 federal workers in 4 federal buildings using that various heart rate variability monitors, and 600 people for 8 weeks at a Lockheed Martin facility. And I can tell you that different people have different desire to know about various aspects of their health. The IT guys were jumped on it right away. They just love monitoring everything. And you can use it as not only a stressor, but it's really biofeedback. It's truly very sensitive biofeedback to help you moderate your actions, behaviors, and so on to optimize health. So for example, the Andrew Weil Center for Integrative Medicine created an app for the 7 domains of integrative health. And since the pandemic, people have just jumped on this and are using it continuously to help them. Again, it comes down to information. It comes down to people want credible information that can help them to become healthier. Those who don't want it won't use it.
Yeah, so that obviously that's not my area of expertise. So
No.
I don't know much about it. But
you.
I'm old school. You know, I believe if you sleep well, eat well, and exercise, you'll probably be fine. And I never look up symptoms of any disease on the internet because I think it would make me paranoid.
I agree with you. I hate using the internet for that, but I've been wearing this little ring here. It's a ring that tracks my heart rate variability, my sleep quality, my physical activity, and I have to tell you, I believe 100% in healthy behaviors. That's what integrative health is all about. But it's hard for people to implement this stuff sometimes for themselves in the context of a busy, stressful lifestyle. So any tools that people want to use, it's fine with me. I didn't mean to jump on you. I love your wastewater stuff. In fact, we want to use your wastewater stuff to feed into our Safe dashboard. So we have to talk.
Okay.
One of the things I think that people are a little concerned about, and this has to do with contact tracing. There are people who interact with other people that they don't want other people to know they're interacting with. Sometimes boyfriends don't want to know that their girlfriend has been interacting with another person. And contact tracing, I think to some extent, it has felt like an invasion of privacy. There are people who hide from contact tracing. That has to do with I know that Tony's not on, but the Constitution of the United States does not provide a guarantee of privacy. We've kind of interpreted that in. So I guess we need to figure out where the balances are in personal information and private information, which could include how much people know about what we ate from what they infer from what we poop. Barbara.
Steve, I don't have a response for that one, but I do have an observation, and we'll see where this goes. In order to do what Ian wants to do, and also to a certain extent what Esther wants to do within the built environment, that calls for infrastructure. I know that when I was at Rice and trying to be able to implement some technology that allowed us, which did allow us to predict the next hour's energy consumption with a great deal of accuracy. We had to increase our metering on buildings. We had to, which required an enormous investment in metering. In order to accomplish what Ian wants to do and what we need to do in general, in order to be able to make buildings more flexible, we need to increase sensors, we need to increase the separation of infrastructure within buildings, and that in itself is a large upfront cost, capital cost in buildings, which can be daunting. And so how do we justify that? And, or how can we bring that cost down?
Well, I think that ties back, Barbara, to a point that you had made earlier about the equity question. And how do we make sure that equal protections are based against the unequal risk, and how the unequal risk is distributed by a whole bunch of different things. And that comes back to how do we perceive what shared comfort is. I really like the point that Altaf made earlier about opening the windows. I like that a lot.
I also, I highly recommend a good return on investment ROI analysis, which is what we do at the Institute on Place, Wellbeing and Performance. Esther, you could add to that. But that's weighing these different factors and costs and seeing how it benefits in the longer term versus just the shorter term. So, and we usually make them an argument, healthier employees are worth it, totally worth it. And costing a little more upfront will prevent more costs later with sick employees and sick leave and productivity issues, all that.
Yeah, Matt Pearson, you made a point that I'd like to invite you to expand on. Are you there, Matt?
Okay. I am here. Can you hear me okay?
We can. Mm-hmm.
The only problem I have right now is that I have a 7-year-old and 10-year-old who are also on computers doing their classwork. So, but at any rate, if you're referencing the Mass Design Group's project in Boudreaux, the project kind of came from a current hospital that they had that had the closed windows, that didn't have passive air systems. And they noticed that a lot of the disease and infection, and I'm an architect, by the way, so some of your medical terminology is a little bit over my head, but nonetheless, I can definitely understand where you're coming from. But in Boudreaux, they started noticing disease and infection going up, and it was also per how many people were in their existing hospital. And so Mass Design Group, they do all sorts of philanthropic type projects kind of worldwide, in particular in third world countries. And they got some support and some grants, and through their research, and this kind of goes to studies of the Venice Hospital, that Le Corbusier did years ago, but how important it is for patients to connect with their outdoor surroundings. And that's feeling fresh air, that's seeing different colors, materiality, the tactile biophilia. And I think it really speaks to how important it is that to know that patients are humans and how closely connected we are with the world around us, and how important that is for healing. Of course, vaccinations and all the medical research that goes into treating viruses and diseases, I mean, that's obviously essential, but it is quite amazing that how much of the healing process comes from the physical touch, the touch of others, like we've talked about, the touch of materials and those visual connections. So I was just sharing this one project as an example. There are many others, but this is a nice one. This had a lot of financial support from people worldwide. I think Bill Clinton, his foundation, Hillary Clinton Foundation, they were there on the groundbreaking day to kind of celebrate this and kick it off. So thanks for calling on me. I hope that was helpful.
Yeah, thank you, Matt.
If I could leverage off of that, I agree, and thank you. I looked at the link that you sent, so thank you for sharing that. And it goes back to a landmark study that Roger Ulrich published in 1984, where he looked at patients who were recovering from gallbladder surgery in the same hospital ward, treated by the same doctors and nurses, and the ones that had a view of a grove of trees left hospital a day sooner, needed less pain medication, and had fewer negative nurses' notes than people with a view of a brick wall. And there have been many, many studies since then showing that this connection to nature is really important. Sean McCann in Ireland, in his bone marrow transplant unit where people are stuck for 8 weeks, did an open window study where they didn't have the ability to look out at a view out their window because it was filled with HVAC equipment that was making the rooms positive pressure to protect the patients from infection. So he used LCD projectors in every room and connected with the city of Dublin and had people watching in real time, either their families or watching the boats go by on Dunleary Pier and so on, art on the screen. So there are ways to use technology if you cannot have the luxury or the opportunity to have an open window or a window with a view. But I agree, and if I'm going to mention my book, Healing Spaces: The Science of Place and Wellbeing, Harvard University Press, where I talk about all of this and how everything that you experience through your senses, whether what you see or hear or smell or touch, and certainly biophilia and love of nature, are all really important in enhancing resilience and reducing stress. And the built environment is essential in helping to shape that.
Well, so a breath of fresh air is more than just a saying. It really is. I think it makes a big difference. One of the things that I'm not particularly sensitive to, but the women in my life are, and that's color and the color in a room. Now I have to admit that I suffer from male genes, and as a consequence, I'm not as sensitive as perhaps I should be. But could you talk about color for and background? Has it been measured to have any effect?
So color, yes, there have been studies. It's easy to measure color of light, so wavelength of light. There's a huge literature on full spectrum sunlight, red light, blue light, and the impacts on various aspects of health. Mariana Figueroa, who also has been working with the US General Services Administration for many years, has shown the impacts of full spectrum sunlight in the morning on sleep quality at night, and the importance of having an open window or a window with light coming in. Color on the wall is much harder to study. And there have been studies by paint companies that have done this this kind of study. Color, so there are two ways that color impacts your health. The full spectrum sunlight will impact you directly. It's going to increase vitamin D. It's going to boost your immune system. So that aspect of color has a direct impact on health. The walls, colors on the walls, or colors on your clothes, or colors anywhere that you see, are more related to associations. So we learn to associate certain colors with increased activity, less drowsiness, more social interactions, and the hotel community, and maybe I think it's going to be spoken about tomorrow. The hospitality industry knows more about this stuff than I think we do in the sciences. The marketing of different kinds of colors that people have learned to associate with different moods. So there's no question that there is a mood association, but you can unlearn those associations and you can relearn other associations.
Okay. One of the questions that someone just brought up, and I think it's very intriguing, is the idea of measuring ROI in something other than cash flow. And there may be a relationship between ROI reflected in lost work time and productivity, and maybe ways in which the built environment can improve productivity and can improve the overall health of its employees, may translate into actual cash flow measurable in ROI. What do you, anybody have any thoughts on that? Because I think that's really important.
Yeah, there's a lot of research that has gone into it, Steve, and it's a big topic where people tend to focus on the upfront cost, which could be in dollars or tens. And I can share some of the research that I've been exposed to in the chat link as well, where they talk about, tens versus hundreds and thousands, where the absenteeism time for employees could amount to hundreds and thousands, while you're worried about ones and tens in the upfront cost of doing the right thing, in terms of, some of the stuff that got mentioned about biophilia, indoor air quality, choosing the right system, building the flexibility, and providing personal control, or localized control, of the local environment to your occupants. There's a report called Stoke Report, S-T-O-K, that came out of, San Francisco that talks a lot about that. And I'll throw a link to that in the chat room.
I appreciate that, Matt. Thank you. Okay, let's just open up the room to everybody who wants to launch a subject.
Hey, Steve, this is Prem. Can you hear me?
Can.
Yeah, if I could just latch on to that last comment. My question was really about not just looking at an organization individually, but we are all part of a larger system. See, I'm sitting here in my, let's say in my office, my company is part of a larger system in the community. What I do within my company doesn't have a direct, I mean, it has a lot of impact on what happens in the larger community, but there's no connection to the cost impact of the community's social issues. I wonder, beyond thinking of my own employees, how can we stretch our thinking to share the community-wide social and health issues? Could that be part of our long-term thinking?
I think that's a really important point. And I guess there's also the context in which we extend this beyond just COVID-19 and looking at that in a more general sense. I guess the larger question is how COVID-19 brings into sharp focus the question about how we interact with one another and the degree to which we contribute to one another's diseases or disease profile. But the larger question is, we're going to hopefully get beyond COVID-19, I hope, and we'll be dealing in the future with other health threats. And those health threats may come in a variety of different forms that could have to do with, take for instance, the Zika virus and dengue fever. And both of those are driven by environmental situations. But if you have open air and no screens, then that breath of fresh air may bring in the mosquitoes that make you sick. So there's all variety of different things that we have to take into consideration.
Absolutely.
Now, coming back to the dashboard, and I'd like to do that for a second, has thought been given to how you might look ahead to the restaurant that you're going to and the sensors that would be required to be put in that restaurant, and the knowledge that you might have, or whether or not you're going to take a ride on an Uber or a taxi cab, or whether you're going to take the A train, for instance, to get into town. Has any thought been given to a look ahead type of proposition, even unto the hotel rooms in which you might stay?
You know, the idea of this is that, and maybe Bo can comment without giving any details as to how we're doing it, because we just filed a provisional patent on this. The idea is that we can link any number of dashboards, apps, and information platforms to this and have multiple layers. Bo, do you want to comment?
Yeah, thank you, Esther. Also, thank you, Stephen. That's exactly, so we try to test this on the University of Arizona campus to have people respond in their sort of objective and subjective perceived level of risk, and in a cluster location. So like you mentioned, in a restaurant condition, in a senior care nursing home, and hotel conditions. I mean, all those applications could be similar. We can show in the dashboard, you see one layer, but there are multiple layers we can show. And hover on the layers, they can check on either face covering, social distancing, or their perceived risk, and all those layers they can be shown. So another beauty is we can look at how different people perceive risk differently. So senior or younger kids or younger population, they may have a different perception of that. So that can be perceived, show spatially on the map. That's another beauty of this. So people who, this is back to science predictive modeling. So when people look at this spatial map, they sort of know an idea where are those spatial congregated risky area or safer areas. So they can choose based on their own perception, their own criteria how they navigate through the space. So back to your question, that's true. We can potentially apply this similar concept and technology to other cluster built environment and apply to that to different populations. So
let me throw out an idea that may reach out to Ian and Matt simultaneously and put this in the context of what you just described. Is there a possibility of developing a real-time sensor that actually senses the viral loading in an air column that could be reported on your cell phone, so that you could look forward to the, if that sensor was installed in your cab or in your train or in the hotel room or in your restaurant, and that real-time sensing could be of value to the potential patron or a person looking forward to say, wait, am I going in that place or not? Is that a possibility?
Everything is a possibility. But that's difficult. The issue with sensors always boils down to really the sensitivity of detection. And when you look at the other important thing is specificity. So you got sensitivity and specificity. And from what I've seen, whenever you increase one, you decrease the other. There's some thermodynamic law there or something. But when you want something that's specific, sensitive, and in real time, that we're a long way off it at present. Let's just put it that way.
Well, one of the things that I was thinking about is that rather than attempting to convert all these mixed air environments, and some of them we're just not going to change. Like if you walk into Home Depot, that is mixed air from the word go. They're blowing fans from the top of the roof all the way to the floor. If you walk underneath one of those fans, you're going to get frozen to death. And so the value of a mixed air environment is that it does mix the air. And so a sample of that air could potentially be more informative than a stratified air environment. And potentially, if you can measure in real time what the viral loading or bacterial loading is in a mixed air environment, or even the particulate loading, because we've got smoke everywhere from California. So the bottom line is that the health of the interior or the built environment might be something that we could sense in real time. But that goes back to the question, Matt, of in a mixed environment, how truly mixed is it? Or are we just sensing locally?
Yeah, so I mean, it's going to come down to how well the system is designed. You know, there's obviously challenges with existing environments. There's only so much you could do to bring them up to speed and stuff. But in terms of monitoring, when you're talking about a built environment, an enclosed or a controlled environment, sensing is a lot more practical than being able to do in an open environment. From a mixed air environment to a stratified air environment, yes, the two systems work a little differently. Assuming that both of those have been designed well, where you have a mixed air system that's doing its job mixing and a stratified system that's doing its job stratifying, it's just a matter of calibrating the sensors, the reading that you get to how it's supposed to be interpreted. Because in case of a certified air system, you would have higher concentration of contaminants at the return grill level, so you read it accordingly. Whereas with a mixed air environment, most likely you'll have a homogeneous environment, so you will interpret that signal accordingly as well. So you can apply it both ways. Again, how you read it is what changes. I'm not a sensor expert, but I think you could apply it both ways, and it could be useful data.
Okay, great. Nancy, did you have something you wanted to say?
Yes, hi. this is actually back to the comments about the application of this model. And I'm thinking about all sorts of ways and all of these presentations, frankly, what this looks like post-pandemic for us. And I think about the interest of connecting subjective and objective information together. When you're talking about the built environment, that's such an important aspect. And you think about all the research that we could do with this, is that, as designers of these environments, we seek to enhance our environment. So you think about, you could be asking people about safety and how they feel around the campus or any community. You could find out the stress areas which you would have to address. You can think about things like, and I think a lot about this in Arizona, the lack of shade when you're moving through the landscape, and how people are, moving because of the extreme heat, and how we can ameliorate that situation. Places of identity and how people identify, and so on and so on and so on. So I could see, as I've said, with all of the other ideas that are being presented here, how we could morph this later. And so it's not just about the pandemic, it is about this broader issue of enhancing our built environment. This symposium is a reflection of this growing awareness and the creative responses that we're seeing. And that I'm really struck by, that is the creative responses of the researchers on this symposium today, and the ones that we will hear from in the next 2 days, thought leaders and innovators. This symposium is also a reflection of months of evolution of a notion that the built environment is a complex entity with difficult problems that can only be solved in transdisciplinary fashion, as we see here today. This understanding became a catalyst for the creation of an unprecedented research effort at the University of Arizona called Restruct. So some of you may not know, unless you've been to our website, understand the history of Restruct, that this is something that we believe might be, if not unique, one of the rarer situations in universities in North America, I would say. It's not housed in one college. It is not the privilege of one or two researchers. In fact, it's sustained by an interdisciplinary partnerships focused on the built environment. And it's with the knowledge that the built environment profoundly affects our wellness, our economic prosperity, our sustenance, our diversity and equity, as well as resilience. And again, back to this 6 months and counting. But also what I've noticed in these presentations today, is we keep on coming back to the central question as well, is that are we thinking only about this pandemic, this present pandemic? And where are the opportunities as we think about this? Is that how do we extend the things that we're learning from this period, and understand that in fact we're dealing with an issue in this moment, that actually innovations and creative responses that could be applied in the future. So this symposium also reflects a maturation of Restruct, which is led by the efforts of Barbara Bryson, and it's now joined in its efforts with the University of Arizona's Arizona Institutes for Resilience, AIR, under the direction of Jim Beiser. Restruct has also hosted different workshops, and we kind of like to refer to it as speed dating for researchers interested in cross-disciplinary collaborations in the built environment. And we've seen many examples here today of different projects that are being done by these presenters, but joining, and not within Restruct, but really as a model of what Restruct is reaching for, is medical practitioners with optical scientists and engineers and lawyers and architects and so on, all coming together to address these complex issues. And these are also people that are doing joint applications and winning research grants to fuel this research, and symposiums that they're presenting at, such as this one. So this symposium is also another innovation with Steve Winston and his transcending incrementalism approach. And doing this TI symposium virtually, I believe also for Steve might be one of the first times, although of course he has his famous Thursday morning talks, but to come together in this way, we're all kind of testing new ways of exploring these ideas. I believe that this first day of discussions about mid-pandemic adaptations, I should say, has been a marked success. But also understanding Steve's method is that we will not fully understand the full success of this for a while. As people reach out to each other, and I've heard some of the conversations going on here today, discuss potential partnerships, find funding, and initiate groundbreaking research. So this is what this is all about. So a sincere thanks to our first 4 speakers today, giving, I should say, very different perspectives on the built environment and hacks to beat COVID. But I was struck by the innovation uniquely derived from their own disciplinary perspectives, but also the common area that's shared by the lived experience of the built environment. So, like all good presentations, we had some great catchphrases that sum up the essence of the subjects that they were discussing. So Esther Sternberg with Bo Yang, Shujin Lee, Althoff Engineer, Philip Stoker, and Youngjun Son. Your watchword, I think, and your phrase that I came away with was public information equals public health. Dr. Ian Pepper, I think, probably wins it for the day with Poop Doesn't Lie. And Matt Bumbla, who talked about that the air we share. And then, of course, Dean Emeritus Tony Massaro, who was reminding us that the Constitution is not a suicide pact. So at first glance, you may, when looking at this event today, you might have been wondering, what are these different, how do they relate to one another? And again, I think it's a common ground, how we variously deal with the common space we share in the built environment. So the mid-pandemic point that we're at has important issues, obviously, for us to consider. And in the spirit of great researchers and thinkers that we've heard here today, they've raised many questions for us to consider, not only in the moment, but as we move forward. So these are the ones that I came away with, is how can we move through the built environment in a way that gives us choice and helps us to manage our risk and stress and reduces the spread of the virus and helps us in our planning moving forward, a question that came forward. The second one is, how do we design and reconceptualize our buildings to be compartmentalized, both physically and in terms of the air we breathe, to control the spread of the pathogen? And how do we, and this was a very interesting one that I was trying to think about at the beginning when I knew that Tony would be speaking and I knew the area that she thinks and writes about. But I could see it as during the presentation how well it suits the day that we're in the conversations we're having. But her question was, and how do we do all of this that we're talking about in terms of the built environment and make policies for reentry that are based on science, that consider the need for good communications and opportunities for feedback and discussion, and balance the rights of the whole to the rights of the individual, and be vigilant for unintended or unseen consequences of the actions we take for all the members of our community. And then finally, and importantly, for those whose sites go beyond this pandemic, and we all do, how do we take the lessons of research during the epidemic and translate it and enhance and accelerate our work in the built environment after the pandemic? So these presenters today have turned and they've pivoted from their areas of expertise, applying it in our lifetimes anyway, because there have, of course, been other pandemics during this unprecedented time and experience that we're going through with this particular global pandemic. It shows the innovation and the adaptability and the relevance of their research and scholarship for us all in our daily lives. So thank you all for your contributions today, and to the participants in the symposium for your continued engagement, which takes us into tomorrow and into the exploration of travel, hotel, and the transportation research in the COVID SARS world. So please stay tuned tomorrow for day 2 of this virtual Restruct Mid-Pandemic Adaptation Symposium, and we'll see you at 8:30 tomorrow morning. Thank you.
Fantastic. Thank you.